Hey, it's Gadget UK here again, back for part 2 of the Pang bootleg repair here. Massive thanks to Glen over at CRG for sending this, just around Christmas time actually, 2024. Yeah, so the next thing I'm going to do is try and work out which ROM sets here, because I think we've got character 1, character 2, or character 1, character 2, forget. Which ones relate to the sprites, because it's the sprites I think that messed up. The backgrounds seem alright, and the bit of the interface you can see seems alright. So I'm guessing it's going to be these for the sprites, because the background data, yeah, is going to be larger maybe, although it's tile based, so I don't know, it could be wrong. It might be, there's a lot more sprites than there are character stuff. But anyway, I'm going to start by I've tried removing like a block at a time and couldn't work it out. I'm going to remove all 4, and I labelled these up previously. I need to make sure those labels are still intact. The first one's not got a label there. Yeah, on the left hand side we've got B, C, D. So that top one's A. I'm just going to stick an A on it. A. There we go. Going to remove all 4 of those. I'm going to test it first just to make sure it's working as it was last time we used it. And then we'll remove all 4 and try it without all 4. Yeah, so pointing you at the screen there, switch it on. We're going via the HDMI upscaler in order to get some video, because the monitor won't handle it. So yeah, I think that's sprite stuff, and I think these are like background tiles, and they seem okay. And again, I think these are background tiles, and I think this is some sort of like, you know, a text layer, an interface layer of some sort. It's weird, isn't it? Yeah, background looks good. These tiles look good. So wherever those are coming from is alright. It's the moving, spritey, animated things that aren't. And when you know nothing about a board, we don't, there are no schematics for this. I mean, I could look at the MAME code to work out which character, you know, which, hang on, let's just get the flat blade, which ROMs feed which, what's his name, you know, areas of the system, like is it tile data, is it sprites or whatever. I might end up doing that, yeah. I might go and have a look at the bootleg support for this ROM set in MAME to work out exactly what's going where. Because I'm still not clued up as to the cause of this, you know, like is it a logic fault or is it actually the ROMs? Because it could be the ROMs. Or if you saw the earlier part, you'll note that there was some shenanigans going on with the ROM set. Like trying to work out exactly what's going on with these ROMs. There's a bit of a mix of, you know, a bit of a mismatch, and I had to, you know, change that first one at least, and I'm not sure I did that right. That might be the issue. Switching it on. So we've got the text there. That's a good sign. We've got exactly the same thing there. We're missing some yellow, but that looks the same. Let's just see if the backgrounds look alright. I mean, if that is the case, it kind of makes me think that is the right area we should be looking at. It's the logic around those and those chips, maybe. Yeah, it's exactly the same look. Wow. Seem to have hit that first time, don't I? I mean, it's almost identical in behaviour, aside from the fact we seem to be missing some colour. Because I thought there's like quite a lot of yellow around there, or a bit of yellow, certainly. So that's got me thinking maybe some 7.4 series around this could be the issue here. I mean, that chip, I don't know if you can see, it's like that on the board. It's at 45 degrees, it's barely soldered on. I've tried pressing there in case it's loose, it doesn't seem to be. I mean, obviously it's not going to do anything now because those chips are missing. But anyway, that might be the next thing I do. I may take that off. I was even contemplating, if there's a RAM here as well, it could be that. I was contemplating taking off the RAMs 1, 2, 3, 4, 5, 6, 7 sockets in them up. I don't think it's these RAMs. I did piggyback with these ones here and these and that. No difference in terms of anything really. I couldn't test the sound because that one's for the sound, but it may have a bad sound RAM. That there though, I'm not sure about. I need to Google that to work out what the part of, you know, what it is. Can I actually get a replacement one of those? Because right now I don't think I have anything that I could swap it with. But the beauty with these ones, if I socket these things up, which is why I want to do that, is you can swap. I've got spares for these, but you can also swap the chips around. Yeah, even if you can't get a spare, you know, you can swap chips and see whether you get a difference in behaviour. It's always nice having the RAMs and the ROMs socketed on any board, because they are the most common failure on anything generally. In arcade boards, ROMs generally always occasionally get bit rot, some failure, some data lost, etc., where they need reprogramming. And it's the same with the RAMs. You get a power supply spike, something goes wrong with the power supply. The RAM generally seems to be one of the things that takes offence on arcade boards, so RAM and ROM, always a good idea to have them socketed. Yeah, I was just about to put the ROMs back in, and I spotted some little gouges like this where a screwdriver's gone in. So someone's removed these in the past with a screwdriver, and I'm thinking, and it's not me, because I never leave her like that. I tend to just leave her on the edge and lift up until it's out. Because, well, from prior experience, this is what can happen if you use too sharp an implement and you go at too sharp an angle. Let's just have a scratch here. Yeah, it looks like it's still in one piece, doesn't it? You can check from the via. I'm just going to scratch the coating off there. And test from there to the via. It goes to the pin. Not joined up, are they? I wonder if they're in pairs, these. Obviously I should look at the pin out of these, because I can't remember what that is. But they're not. Hang on, yeah, it's joined to alternate pairs, isn't it? So it's like these two are together, and I guess the other two are going to be together. Yeah, there we go. And it's the same with the pins. So you can see if you've got any missing data bits this way. Although that might be an output enable. There's nothing on this. Oh yeah, there is on the second one. First one. Yeah, so I'm going to spend a few minutes just doing that, going up and down that pair and that pair, that pair and that pair, etc., all the way along to see if everything's joined up and we haven't got like a missing address line, a data bit, etc. Yeah, I'm confident my work with the ROMs there was right, because this one came back as 12 from the bootleg set 3, and then it went 11, 10, 9, so 12, that's right. So I think from a ROM perspective things are alright, and I checked obviously the connectivity, and it's like those two are paired, and then one of the address lines up here goes to those two and those two, which is a bit weird. It's like things flip around on an address bit. Nevertheless, I think we've ruled out that bank of ROMs. I'm just going to switch it back on and make sure it looks the same. So it must be some logic around that, or RAM. I think the next thing we're going to do is get that off in the socket, just because, well, it's at 45 blooming degrees. It's like you'd have to be crazy to leave it that way. Let's show you. Wrist strap is on. If you have a look at this chip in question, you see that? It's like right off, yeah? It's like maybe the pin there is not even making a connection. That's a possibility. So I'm going to remove that and socket it up. We'll do that first, and then what I may do is remove these 3 RAMs here. I think they're all identical. The 6116s-10s, yeah, they are. Yeah, all 3 of those. Socket those up in order that I can swap these different types of banks around. If we make some progress there and we fix the video, I'll do the same thing over here with the one for the audio, because I suspect that might fix the audio. It's most likely to be that, unless there's an 80s dead over there. But again, it's one of those things, maybe your CPUs should be socketed up as well. So I don't know, we might socket a few things up just for the heck of it on this one, and including those RAMs there. Although those RAMs, I'm damn sure, are alright. I mean, it could technically still be that RAM, but I don't think so. The board looks so much cleaner than it did at the start. There's obviously the odd bit of markage and stuff. Which reminds me, I'll have a quick look round here with magnification. It's still streaky, as you can see, it still needs more cleaning. But I'm just going to have a scan around this area, just to make sure I don't see any gouges, scratches, bad solder points, etc. Yeah, you see like we've got like a little nick or something there. I think that's all it is though, it's just a little mark. I don't think that's actually any damage. Yeah, that's alright. Can't find it now. It's the problem using a microscope. You're so close to the bleeding thing, you can't actually see anything. Right, so we've got something here. Again, just like a little hairline thing going on top. Oh, I can't hold it. Yeah, it's just cosmetic. It's not gone through. Same there, I think. Any of these things that I scratch off, I'll put some solder mask on them later. That looks alright, I think. Anyway, I'll continue looking around. Now, do you remember in the earlier part where I was like, these two traces are broken, and then I was fixing one of them up, searching around the board, and I was like, I can't find the other one, it's gone. I said, it's alright, it's fine, I must have imagined it. No, there is another trace, you can see it hopefully there. At the under that there. So yeah, that's where that chip was really hard to get off, and you can see how little solder there is on some of these. There's like literally no pad, and yeah, the pads are just awful. The PCB quality is awful. So I'm going to get out the. In fact, did we pre-tin that? I think we may have done. If I can find the bleeding thing under the cat. Yeah, we did. I pre-tinned it, and then I couldn't find where to stick it. So I'm going to just go around the top of that via. Be careful, not try and tear the thing up. You saw a bit of tear off there then. There. I can add some more solder later. Anyway, that wire's in place. That fixes that trace. I wasn't trying to be poetic there. Let's now see if that's made any difference. Hopefully it will have done, but we might be under the problem yet. Oh my god! Hang on. Oh my god, it's half fixed. We have got some sprite data back, but there is still a problem. Well, I'm kind of glad that wasn't the only problem, because I think I would have been a bit disappointed if it was perfect, but you know what, it's not looking bad, is it? Yeah, our sprite, look, he's coming and going, and he's half there, half not, but we've got some positive progress there. To coin. I can see the balls, but only when things are on the right hand side, seemingly. It's weird, isn't it, how the P's like over that side. Like something's not being reset or something, a latch or a counter maybe, could be a counter problem. But should this not be over there? I think it should. Well, I feel happier now because we know the ROMs are alright, and that address decoding, I'm just going to press around there just in case it's like bad connection now. And this is the other thing, I'm back to pressing around the board. Because you need the screen up first down. Because if you do have a loose connection somewhere, a bad socket, something barely connected, it can influence things. So coupled with the fact we've learnt that the pads on these are super fragile. As soon as you put a desolder pump on there, desolder station, and heat, you lose the pads really easy. I mean, totally like within a second of touching it. So I'm going to go straight to using hot air here. I'm just increasing it. Hang on. I'm going to go with the magic 405 degrees. I'm going to put the extraction tool on this side here, and obviously one side of this is already lifted off. So the point is, it should come off relatively easily. Yeah, I think you can see what I'm doing. I'll try and find it against that one. Yeah, so this side here is not even in. The side nearest me. It's just preheating around here. It still takes a while to remove a chip like this, certainly when you've not removed the solder. Generally I'll try and remove the solder, but this board is so pants. I don't think I want to risk it. Of course, because it's so pants, it may delaminate really easy as well. Oh my god, that is welded on the board. It's not coming up. I really shouldn't be soldering here, right next to these sockets, but, well, I don't know, beggars. Maybe choosers. I'm going to go from this side. It's because of the crooked nature of how it was, there you go, originally soldered half on each side. Like this side's literally surface mounted. Hence that side coming off really easy. I thought that was going to be much easier than it turned out to be. Yeah, heating from this side definitely was the right approach. Sockets look alright, nothing here melted. Yeah, they're just lukewarm. Yeah, I go about things in a strange way compared to lots of people. Lots of people do all the clean-up work and repair, you know, fix cosmetic things and things like this when they get to the end. If they get to the end. I just work on the premise that I'm going to continue to the end regardless. You know, I'm always going to get to the end of this. So I may as well just do it now, is the point. And it may, this is the thing that sometimes happens, things that you think, oh, I'll do that at the end, ends up being something to do with the problem, or a problem, if you see what I mean. There's loads of chips, and I'm going to focus on that next, I'll show with solder all up the legs, like they've had wires on there or something. Or maybe they were taken off junk boards, and this is, you know, assembled out of bits and pieces, if that makes sense. I'm more inclined to think that's the origins of the solder points on them. I don't think that's absorbing the solder at all. No, it's not. Joey. I may just flip it over and try and use the desolder pump instead, if I can find it. Where's it gone now, that? It's here. Yeah, I think not having the chip there makes it far easier to unblock those tiny holes. So they are, that's the problem, they're very small with very small pads. That didn't unblock that one. So we may lose a pad here yet, I don't know. Can't tell what's going on with that now. Doesn't sound very good, the pump, does it? It's, there you go, it's sped up a bit there. That didn't unblock. Didn't unblock. It did that time. It can just be a consequence of how much solder there is to remove. The key is pushing the silicone over the top of the nozzle to get suction around the point, if that makes sense. You may think you're not supposed to press the nozzle into the pump, but this is why it has a silicone tip, because silicone is heat resistive. You can melt it and they don't last forever when you do this, but it's the proper way, there you go, to make sure you get suction all around the area. I'm sure this is not going to have any bearing on our fault at all. I just don't like the way the chip was on the board. It looked like it had been thrown together by me, age 5. That's what it looked like. I mean, that's one thing I can say. I've done some questionable things in my time, even when I had a career in electronics. But I never, ever, ever installed a chip that bodgily on anything, even when I was like 18 and not 19, I think, maybe. And new to soldering, new to the repair industry, and my boss went, fix this Spectrum, move that RAM, take these chips off, and I tore loads of traces up. But never did I ever install a chip that bodgily on any board ever. You've got to be completely careless to do something like that. It takes an awful lot of effort to make a chip that crooked, is what I will say. Hope I've not offended anybody saying that. If you've done one like that, I'm not blaming you. You know, you learn, I guess. But yeah, I mean, if I had done something like that and I noticed it, I'd be like, I've got to take that off and redo it. It looks horrific. Anyway, the chip came off okay. And its legs are alright. Whether it works or not, I don't know. Let's get a socket on there. Yeah, what I would say is a wee bit barbecued here. It's now gone from having a crooked chip, well, like, which moron soldered this on, to barbecued by Gadget. What moron barbecued this board? I don't know, it might clean up a bit with some bleach. I don't know. I tidy up in here before I do each bit of this, and then within 20 minutes I've got stuff everywhere again. It seems to take no time at all to get tools all over the bench, bits everywhere, flux, solder, you name it. Anyway, I'm just going to clean around the carton board, and then we'll toothbrush it. And of course the other advantage of not using the desolder pump to remove it, and the desolder station, any traces that run nearby, they're going to be fine. I'm not going to have done any trace damage to things that are next to pads, you know. Like we did over there. When I say we, I mean me. Like I did over there. You didn't do it. We didn't do it together. The only we are the people that watched and laughed. That's it. Don't do it like Gadget. Oh, here we go. So, my usual mask. But it seems crazy because the wider board still needs more cleaning anyway, but it's relatively clean compared to where we were at the start. I mean, it really was dirty, this, both top and bottom side. Particularly bad. There we go. Yeah, you can see it's barbecued just ever so slightly in the light. Yeah, you can see. I can see it on the camcorder more than the eye. There is a bit of a brownness around there, but anyway, that's that done. So we tidy the bench up, and I'll clean up the legs on that chip, and we'll get that chip back in. I may even just try a different chip there actually before I do that. Yeah, and I'm always curious to test a board without a chip to see what it does. So you'll see we get like a flicker in there, and then like a scan line type effect. Yeah, you can see that very clearly. So it's like every other bit of data is missing or something. Anyway, switch that off. I'm just going to straighten up the legs. You have to be careful not testing too long doing something like that, because let's say, for example, I'd removed a chip there that, and this might be the case, that is controlling chip enables output enables us to show whether active or low, and they just float, and they're floating into low or floating between high and low. Then you get contention. You can actually create a problem by testing without a chip. It is possible. It's unlikely, but it's possible. So, and it's the same with piggybacking, you know. You've just got to use a bit of common sense, really. You wouldn't want to leave it powered for like an hour or something with something missing, or piggybacked. We're talking about quick, easy tests here. Didn't have to strap on when we did that, but yeah. And I'm sure there's nothing wrong with this chip, incidentally, because well, we've seen the behaviour when you fit it. I'll try it without it. Get into that socket. There we go. It just looks a lot better now. It's on there. Yeah, the video's back. Yeah, it just looks a lot better now. But we've still got this issue, and I think it's strange, isn't it? It's like we're getting half. It's misaligned to the right. So you know what? Something is not flipping there when it's swapping between banks or something. That not really banks per se, but maybe something's not been reset. I think that is just a simple thing. It's just, well, I say a simple thing. A simple thing. It's going to be hard to work out which one it is, though. What it is. One of the 742 somewhere. Something's not resetting. Maybe one of the counters or a latch. But you see, it might be in a different area here. I'm thinking this is not about sprites now, because I think that aren't the tiles messed up? I don't know. You know the way it keeps putting a split in the middle there. No, that's all right. So the background tiles are right. So you know what? It does relate to the sprites. And as the sprites come here, that's it. They're getting cut off. Mind you, that's right. It's in the right place, isn't it? Bouncing between those two things. So it's not like it's positioned incorrectly. It's just drawn incorrectly, I think. But it's not all the sprites, is it? Because let's just wait for that one again where the walls are there. If the ball's bouncing in between them, that sprite's positioned correctly. It's definitely a case of we haven't got anything this side, and I think he should be over here. Maybe I'm wrong, maybe he should be on the right. That's what I'm trying to get my head round. Yeah, just to rule out that, say, some RAM somewhere is not used for the playfield, and it's unlikely, because you know what, you'd be getting everything in one spot. If RAM was related to this issue, all the sprites would all be in one spot, because there's like nothing coming back, unless it was just randomly coming back in the wrong place. But anyway, experimenting with the RAM here, I'll show you if I get a chip on top of this one here. You can identify this is a faster one, so it's going to respond slightly faster, which means you're going to get slightly screwed up values. And if you look at the screen, we've got a colour problem, so I know that this is colour RAM. Totally messed up there, colour RAM. So, yeah, sometimes just a little bit of experimentation, you know, and lifting pins or isolating a connection can give you a clue as to what a specific type of RAM does, if that makes sense. Try the one above there. You'd expect the same thing. Yeah, there you go, blue, look. So that's colour RAM, that pair there. And I think this side here is for the sprites. So I've got colour, sprites. There's one here, I'm not sure what that is. Maybe that's the sprites, I don't know. But I mean, I think I've just done this one. I've done all three of these ones around here. And yeah, you do get effects on the display because this chip's faster. There you go. See, it's kind of like giving the wrong sprites now. So that tells me that it's for sprite data. Yeah, so I just thought I'd show you where we're at. I'm focusing on the sound issues at the moment, so I've switched this on. Put this near the microphone. You might be able to hear that. I will if I turn it up. Hear that? Switch it off and on. Nothing now. Hang on. Yeah, it's intermittent, but mostly makes like buzzing noises, etc. Garbled. So, very interesting. You can hear it there. Yeah, so I'm thinking we've got a digital sound issue. This output's digital sound, and then we've got, I think, a little DAC or something here, but there's also a DAC here, I think. It's actually it's the same thing that was on the Punisher, an M5205. It's speech synthesis chip. It's a digital sound output device. So I'm not sure if both of these are going to the same DAC or whether they must be doing, because that doesn't produce analog output, does it? I don't think. I'll check that, the YM3812. But anyway, on AliExpress I've ordered a new one of those, a new one of those, and a new one of those. The chip here is just an op amp. The outputs, like most op amps, are on the outer edges, you know, like pin 1, the last pin on this side, pin up here, and the pin over there. And we are getting sound, so the op amp is going to be fine. But there could be something else. I did notice if you remove this gal here, it's actually a PAL, I think, but if you remove this, you get no sound at all. That's a bit worrying, because this is something to do with address decoding for the sound. There's obviously a chance the Z80 could be playing up. I've scoped its data pins, everything looks alright, it's got a clock, it's getting a reset. The ROM, you can see I've put a different ROM chip there now. I've got the old ROM here, and put the same main sound ROM on there. It's exactly the same as the other one, so the ROM's alright. Could be a RAM fault there, but it's not socketed. Looks alright on the scope. So very difficult to diagnose. Anyway, we've got those 3 chips on the way, so we'll see what happens when those things come. I'm going to start with these 2 though, rather than that. Probably that's going to be the first thing, that small chip there, and see what happens. It may be we get some of the sound back and then some other sounds missing, I don't know. Or it may be this, and if it's this, it's game over, because the equations for that are not available. I mean, what I may do at that point is do some connectivity tests and try and work out what's connected where in respect to this, and then have a look at the MAME ROMs, you know, the code for MAME, and see if I can guess what this may be doing based on what it's connected to. Let's say it's the output enables for these or something, or something for here, clocks or something. I might be able to sort of have a guess and have a go at creating my own code. I don't know. Those are for colour, the 138s or whatever they are there. So it's easy to, you know, start to probe some of these things and work it out. And on occasion, just briefly short a pin to the pin next to it. In other words, if you've got, you know, a pin that's not doing much, and then you've got a pin that's pulsing, just as long as it's not 5 volts or ground, just briefly just short them and see what happens on the display, because it could give you a clue. Obviously you could kill the chip doing that. So I'm not really sure which way to look. I've looked at some of the counters, the 161s. There's a bunch of them here. Those don't seem to be the issue. I'm trying to think what would cause it to start offset, other than some sort of latch type thing or a counter, maybe. I'll try a 161 again over the 4 different things here, but I've ruled out the one that was in the socket because that's a 161. But then below it we've got 3 other 161s. If the position was being affected, you kind of expect the chips to fight and something to happen different, you know, visually. But, well, we're not seeing that, so I think the counts are alright. Still starts on the right side. I mean, we're pretty much there, aren't we, really, apart from the sound, which I think is going to be another world of pain. Yeah, adding this bit in at the end to try and help you understand how some of the basic principles work with something like the graphics side of a board like this. You know, they obviously rolled their own using 7.4 series rather than, a bit like we saw on the Punisher. Sometimes you get, you know, a CPLD, so there was a square CPLD, a PLCC one on the Punisher that did lots of logic stuff to do with the graphics. Here they've kind of just exploded it out into 7.4 series. Now, one thought I did have, and there'll be a link down below to a channel that you really should check out. It's a very good channel. I've learned a lot of stuff watching his channel, actually. He's built a number of different systems like VIC-20, C64, Spectrum from nothing but 7.4 series and EEPROMs, using an EEPROM as a state machine. And that's one thing that I did contemplate with the graphics side on this. I didn't talk about it. I think I cut it earlier on. But I was contemplating, maybe there were so many EEPROMs on this board, maybe 1 or 2 of them were for a state machine in order to replicate the timing you require to get the video display. But I don't think that's the case. I don't think there is a state machine on this board. But how does the video work in general? Obviously, you've got your X and Y, you know, in terms of your display here. You know, you've got horizontal and vertical, you know, your scan line, you know, if you think of the CRT, you know, it draws a line, flies back at the end, flies back, and you get your image. In terms of how do you get display, how do you get the graphics data for your sprites, for your tiles onto the thing at the right time, you need to be counting. You need to be counting every single scan line as you go down. You know, you need something to increment so you know which scan line you're on. You need to increment pixel count, you know, a dot clock of some sort to work out where are we. Oh, we're at this point here on this scan line. So this is why you get counters on a lot of boards like this, and there are quite a few counters on this board, but not just for counting where we are, but also when you get to a point down there, you might be checking each dot clock, you know, each pixel position here. Is there something to draw? Is there something to draw? Every single point as you're going along. And then of course you can have some, you know, logic there to go, okay, where are you looking? Where's that data stored? Say sprite data. Let's think about sprites here, because this is where our problem is. You may have some RAM somewhere on your board. I'll put S-RAM. It's not S-RAM, but I'm putting S-RAM as in sprite RAM. So there may be some RAM that holds nothing but sprite data, and that sprite data will be in a fixed format. You know, it's a certain layout in that RAM. You know, it might be, I don't know, 612 bytes or something that define the XY coordinates of where a sprite is. Maybe it's palette entry in some sort of palette RAM. You may have, and we have got palette RAM on here, so you may have PRAM I'm going to put, but that means palette RAM, not PRAM. PRAM is a different thing, as is SRAM. Yeah, so that's not SRAM, it's sprite RAM, and that's why do they call it P? Yeah, pallet RAM, that's right. So the point is, the data that's inside this SRAM here, let's say we're looking at the verse sprite, might be a tiny bit of data in that RAM at the starting at 0 maybe, that's 16 bytes long, that has an XY coordinate as the first 2 bytes. It might even be nibbles or something, it might be, you know, there's different ways you could store that. Might only need 4 bits depending on how big your screen is and how those XY coordinates work. But the point is, the first couple of bytes in there may dictate your X and your Y here, like start on scan line 3 and on pixel, I don't know, 90 something over here we've got a sprite, and the next part of data in that SRAM may well be, what is the sprite data? It may or may not contain the actual sprite itself, but a lot of the time it would be an index. You know, this might be like, I don't know, 73. There might be a value, a byte in there of 73, and that 73 may relate in the EEPROM. If you go over here to EEPROM, obviously we've got many EEPROMs, but the EEPROM that holds the specific sprite we're looking at here, it may be pointing to, you know, a sprite in there. So we've got a sprite in there that's, I don't know, 32 by 32 pixels, so size wise, I don't know, it could be 256 bytes or something, I don't know, something like that, 128 bytes or something. And then you need to get the sprite data out of here, overlaid, you know, drawn here for so many pixels. And this is where you might need another counter. You might have a counter here, count, I'll just put, yeah, in badly written English. So you may have a counter related to this, just like the counter related to the XY here. Does that make sense? And then you may be like, how do we get the sprite data out? And you may then have a latch. Yeah, you can see it's getting a bit bodgy, this. Latch, and maybe it's an 8-bit latch, and what you want is to take 8 bits at a time from your EEPROM. So it's a case of using a counter to count your 8 bits, latch your 8 bits into there, and then, and all this is obviously instantaneous, all this is happening within, you know, a nanosecond or something or less, as it's waiting to draw this pixel. Is there anything to actually draw there? And the latch data then gets, I don't know, maybe serialized, because if you think about it, it's got to be serial. This is doing one thing at a time. So then you've got your 8 bits there, and then for 8 counts, you know, 8 pixels, this is the thing you get, you know, 1, 2, 3, 4, 5, 6, 7, 8. You've got your sprite data starting to be drawn. Does that make sense? And this is the thing. So this is why you get lots of latches, you get lots of counters, and there's this relationship between the RAM, the ROM, and your 7.4 logic in terms of how to, you know, serialize and sequentially draw the bits of pixel data, and obviously taking into account your pallet RAM. You know, I'm simplifying things here. You might not use the pallet RAM for this specific thing, but the point is, there's a number of different components to just draw a sprite. So at this point in the video here, what I ended up doing was taking some 7.4 series, and I was focusing on latches and counters, and I took one and piggybacked, and literally within a minute of trying 1 or 2 chips around, you remember the top side of the board? I'll show you a photo. I was like, up here, I think that's the sprite area, because we proved that with the EEPROMs. Yeah, 2 minutes later, I worked out the issue. Yeah, the best I could ascertain is that the problem is somewhere around this area here, I think. I've just got some 273s, and I was actually right. I stuck it over this chip here, piggybacked. I've got some of those coming actually. I didn't realise I had any, so I ordered some, thinking, is it going to be that? And you'll see now that piggybacked, the video straightens out. Look. Obviously it's jumping around because it's fighting with the chip below. That's the issue with the video. I'm so pleased. So I'm going to take that chip off, get a socket on there, and that's one problem down. It's just the sound issue. We're waiting for those 3 chips, aren't we? So is that going to fix it? I don't know. I did wonder if there was another 273. I was thinking there was one over here. There isn't. It's another Gold Star. These Gold Star chips, I think, are notorious. I remember a few people, including Luke Morse 1, mentioning these Gold Star chips fail an awful lot. There's a 374. I don't think I have a 374. It's over here. I'm kind of thinking it could be that 374. Actually, I've got 70% confidence that might be a problem. So I'll go and have a look. After we've dealt with this one, I've got to have a look to see if I've got any 374s anywhere. If I've not, I'm going to order one anyway, because chances are that'll arrive before those other ICs do. Yeah, so you can definitely argue I lucked out with this repair, because had there been a problem where I was stuck with a black screen, well, yeah, it would have been a lot more difficult, is the point. It's amazing how many people out there are proclaimed experts who want to tell me how to do what I do on my channel. That's something that really makes my blood boil. It's like overall giving a bit of advice. But I had a guy recently say, don't take this the wrong way, but you seem to take an awful long time to do things when you can do things much quicker. Like, have you got an ultrasonic cleaner? I'm like, yeah, I have an ultrasonic cleaner. It's not big enough for a board like this. Even if I had one, would I be using it? No, I wouldn't. I'd be cleaning it like this way first to get rid of 99% of the junk and then put it in the ultrasonic cleaner. Why? Because otherwise you're cleaning out your ultrasonic cleaner every 2 minutes, yeah? You literally have to keep replacing the fluid in it. Certainly when I use IPA in it, and I use IPA in it because you know what, again, absolutely perfect end result with no streaks, no dirt, no marks, no nothing. So the point is, I work the way I have evolved to work, and I see, other than it being time consuming in my process, nothing wrong with it at all. So the last thing I need is people telling me how to do my job, basically. And if that annoys you, I don't want to annoy you. You do things how you want to do things, but I do things how I want to do things, and I show you how I get the results I get. If you want to get results in a different way, you can do that. But I mean, anybody who knows me has seen my work. Andrew Littleboy's a good example. That 1200 went back to him and he was like, oh my god, how tiny the solder points are and how tidy they are. Yeah, and I'm not being big-headed, that's what he did, and I was delighted to hear, see that he could see what I could see, that the board was pretty much pristine. You'd think it had come from the factory, like a factory repair, it was that good. Like no dirt, no marks, no nothing. Yeah, so like that chap was also saying, you can use the chem wipes or something, it's quicker and it's easier than mopping up and all this. But that's not how I want to work. It developed the technique now, like I say, going like that with the cotton bud, and then creating myself a little mask here. And yes, it's time consuming, but you know what, there's a certain amount of satisfaction that I get by doing this, and the end result will speak volumes. Great if you've got a giant ultrasonic cleaner that gets rid of every single bit of, every streak and every whatever. That's great. I'm pleased. I'm glad that only takes you a few minutes to do. It takes me a lot longer. It takes me several minutes, 10 minutes maybe, to do what I do here. But I'm pretty thorough and meticulous. If there's dirt left on the board, it's just because I could not be bothered cleaning it off. It really is that simple. It's like when I focus like this on a specific thing, I make sure that it looks absolutely spotless. That's the point. It's granted, I'm not using the chem wick wipes that person is insisting that I use, and an ultrasonic cleaner that's this big, etc. I actually think there's more problems using an ultrasonic cleaner. Not just about cleaning the fluid out, but drying it off and stuff. This would take ages to dry off an ultrasonic cleaner. You have streaks absolutely everywhere. I know that just from when I hand washed it with pretty strong, soap. Yeah, we hand washed this at the start. An ultrasonic cleaner wouldn't really have made that process much easier, if you ask me. You've still got the same manual amount of clean-up work afterwards and stuff. Some things in life, as long as they are wide, they can seem like it's a cost-cutting, time-saving thing. And then when you actually start to do it and start to time the things, do time comparisons and stuff, you'd be surprised at how what you thought was quicker ends up not being quicker. or creates a complication that means then things take longer. Yeah. Anyway, that's chip on. You can see a bit of heat markage again from the hot air, but only a little bit. Right, so let's now get that chip in. That's the new one, isn't it? And hopefully we should now get the full play field. Anyway, I'm glad I ordered some more 273s because that was my only one. And I think I had that in stock for maybe, I want to say BBC. I think at some point I saw one on a BBC and thought, oh, I think I need one of those. I can't remember, it might not have been. It could have been for the Punisher, but that had 273s on it as well. Multiple D-type flip-flop, isn't it? It's got like 8 of them in it or something. What do you use flip-flops on a board like this for? Registers, yeah? You know, to hold data, and you can independently clear and reset them. Maybe it's for sprites. Maybe it can have like 8 lots of sprites in there or something, and that's the sprite register. Something like that. Maybe it's just as a whole, not resetting or clearing or something, I don't know. Anyway, got the... I'll switch it on. See what happens. Oh, God. Now it's even worse. This is something not joined up on that socket, isn't it? I don't know. There must be some damage there now. I knew that was going to happen. I just knew it. Yep, full disclosure, here we are, 10 minutes later. I take the socket back off. It doesn't work, and it's because there's a bridge somewhere on the top. This is why I took the photos, but you know what, it didn't help me. And I knew it wouldn't, because nothing ever does when you get a problem like that. Unless you're really lucky, but you'll see what I mean if I just go over this. I can see where it is straight away. I was looking at it on the photo and I thought, why didn't I inspect closer before I soldered the socket on? It's one of those things, you know you need to do something and then you don't, and you're like, I wish I had. I can't see where it is now. It's one of these here, it's like, can you see here? It's like you've got the smallest particle of solder, I think. There was one that was a bit more visible somewhere, I can't, no, they're here as well. Yeah. And look, the pads are awful. Despite the fact, well, there's nothing on the socket, I didn't lose them. They must have come off with the original chip. Anyway, I need to try and, well, work out where the short is now. Yeah, it does. And it's seemingly not joined there, but that is the problem. Like, not necessarily there on that pad, but maybe on one of these other ones. Like that one, for example. Yeah, look, that's joined and it shouldn't be. Oh, God. Things like that are so annoying. Like, how's that even happened? It's just that little bit there. It might have been from when I used the braid. Yeah, that'll be enough to do it. Yeah, so got those one or two little bits of bridges removed here, and a bit of UV solder mask just on those little bits, just to stop the solder hopefully flowing from the pad to the trace that's right next to them. These PCBs are crap. They really are. The quality of them is just shockingly bad. And what I mean is, you could get the cheapest PCB developed by, I don't know, JLC, PCB, PCBWay, something really cheap, a really cheap prototype that costs you like £1 or something, and the quality is 100 times better than this. Yeah, that tells you everything you need to know. It's a sign of the times, though. In other words, boards like this, built to a price back then, and this would have been an expensive board because it's huge. Yeah, the quality was just not what it is today. These days the quality is just infinitely higher. Right, after that little detour, cheesed me off no end, that. There's nothing worse when you have to redo something. Anyway, let's try that. I put the minimal amount of solder on this time just to make sure. Yeah, I think we had a bad power connection there. It's working, thank God for that. So we've got this little glitching thing going on here, so you know what, there's some other issue, isn't there? It isn't just that. I did wonder about that glitching. Yeah, it's better. That glitching might be because there's no bleeding decoupling caps on there, It's like, now I think about it. Needs some 100 nanofarad caps, doesn't it? Right, I need to get a controller connected up, don't I, to actually have a bit of a play. Right, so I inserted 5 coins and pressed start, and it's working, isn't it? Hey, it's a great game, this. Oh god. Yeah, it doesn't quite fit on the screen. I think this is just about the resolution stuff. Got these 6 coins again, or 5 coins. There we go. Continue. Makes me appreciate how great the home versions of this are. Check out the Amiga version or the ST version. And actually, many of the other versions, like the Spectrum version, the Amstrad version. I don't think there's a bad version of it. Point is though, those 16-bit ones, oh, I've run out of lives again. Yeah, those 16-bit versions, the Amiga and the ST in particular, are just amazing ports. Yeah, so I do hope you found that interesting. A massive thanks again to Glen at CRG for sending this board. There'll be more about Glen in the next video as well. I know we talked about him in the previous video, I haven't done in this one, but yeah, this video was going on in length a little bit. So we'll come back to have a look at Glen's channel in part 3. You can see here I tested that chip on the T48, and I also scoped around that area before we even tried to piggyback, and there were no anomalies there. And this is one of the problems when you get a problem with a chip like this where the failure is internal to it. Maybe, you know, in the case of a flip-flop like this, maybe it's not clearing, it's not setting properly. On the output, when you scope it, it looks alright, looks fine. The only way you'd know there's a fault is if you did a logic analyze, you know, capture. This is why lots of guys in the arcade industry, or the arcade repair industry, they have special test equipment where you can connect a pod up, you know, a CPU pod for example, that goes in place to the Z80, and you can drive all the address lines, the data bus, you can check the RAM, you can check the ROM, you can test address decoding, you can one-step the CPU, you can do all sorts of clever things like that. Arcade boards can be very hard to diagnose without schematics, without a logic analyzer, without understanding all of the architecture there. And it can be quite hard with the vast amount of different 7.4 series families and all the different chips you get on a board like this. Yeah, it can be very time consuming. So in many ways I lucked out with this repair really. The faults were simple to diagnose. But hopefully you could tell from this video that a bit of experimentation, you know, the odd piggyback, the odd short pin, the odd remove a chip, maybe remove, I don't know, an output enable or a chip select or something so that the chip's not controlled, it's not driven, it's not enabled. You can actually start to learn about a board like this, and just looking at the different 7.4 series, you know, if you identify them, you can go, oh, that one's a counter, that one's a latch, that one's a buffer, and you can start to piece together how a board like this works. Anyway, please join me in part 3 and we'll have a look at resolving the sound issues and yeah, a few other things just to tidy this board up. Hopefully you found that interesting. If you like the channel, please see the Ko-fi and Patreon links down below. I need support on this channel more than ever. We've lost so much support over the last 6 months. If you can support the channel, I'm super grateful for that, and I'm super grateful for everyone that supports the channel, no matter how little or much you've supported the channel for. Thank you very much. Catch you in the next video.